Today we will be finding equivalent fractions, writing fractions in the simplest form, some mixed numbers, and dealing with some improper fractions as well. So let's take a look at our first problem here, and it says we're going to write the fraction in simplest form. So what we have to know are some divisibility rules. So let's take a look at one of the rules that we should know. It's dividing by 2. Well, if we have an even number, then we can divide by 2. Another rule that will help us out is dividing by 3. So divisibility for 3 is when we can sum the digits, and then that sum 3 goes into. So sum digits. And if we can divide that sum, if we can divide it by 3, then we can divide by 3. Another rule would be 10. If we can divide by 10, we know that it ends in a 0. Or if we can divide by 5, it would end in either 0 or 5. And so what we want to end up doing here is looking at our first one. I see that both numbers are even. So when I look at even numbers, I see that we have an 8 here and a 0 here. We can divide both of these by 2. And so what that leaves me with is 9 over 10. That would be my answer. So I cannot simplify it any further because 9 doesn't have any factors that are similar to the factors that 10 has. See, 9 has factors of 3 times 3. 10 has factors of 2 times 5. You cannot reduce it any further. So 9 over 10 would be our answer. Taking a look at our next one here, we have 12 and 32. So we just look for common factors. So I've talked about even numbers. They do have even numbers, but I see a bigger number that goes into it. So if you see a bigger number, go ahead and find it and then use it. See, I see 4 goes into these two numbers. So that tells me that if I divide 4 into 32, that goes in there 3 times. 4 into 12 goes 3 times. 4 into 32 goes 8 times. So 3/8 would be our answer. Now if I had divided by 2, I would end up with 6 over 16, and then I could do it once more, dividing by 2, and I'd end up at the same exact answer. So lots of ways to get these answers. So if you didn't see the biggest number that goes into these, you could always start with maybe 3. 3 goes into these two numbers, and if I do that, I end up with 8 here. 3 goes into 36, goes in there 12 times. Now these are both even numbers, so we could reduce it a little bit more. We could take out a 2. If you didn't see a larger number, you could start with that, and you'd see, oh, well, I've got 4 over 6, and I can reduce it once more because I still have even numbers. So I can divide now by 2 over 2, leaving me with 2/3. So we could have gotten the answer a little faster by dividing by 12, but if we didn't see that, then we'd have to reduce it this way, a little bit at a time. Same thing here. You might not see the big number that goes into these, but you do see how they end in a 0, and this one ends in a 0, so you can divide by 10. So when you're dividing by 10, it cancels out those zeros, and so we're just left with 105 over 200. Well, now we have one number that ends in a 5, and then the other number ends in a 0, so that tells me I can divide by 5. And so when I do that, 5 goes into 10. See, I'm doing the 5 into 105. 5 into 10 to start with, that goes 2 times evenly. 5 into 5 goes 1 time, so that's 21. Here, 5 into 20 goes in there 4 times. 5 into 0 goes 0 times. So 21 over 40 is my answer. Well, now we're supposed to find out whether the fractions are equivalent. There's a few different ways to do that, but I think the easiest way is to reduce the fractions. If you just simplify the fractions to their simplest form, and if they are the same, then they're equivalent. If not, then they're not equivalent. So if I take out a common factor of 2, 2 doesn't go into 15, so let's do a different number. Let's go with 5, since they both can be divided by 5. I end up with 2 over 3. Over here, I could take out a common factor of 4. I see 4 goes into those two numbers. And I would have a 3 over 5. See, 12 divided by 4 makes 3. 20 divided by 4 makes 5. You see how these numbers do not equal? Well, they're already reduced as far as I could go. They're not the same, so that means they do not equal. So they're not equivalent. So we would say no in this case. Over here, same sort of thing. Take out the common factors. See what the reduced form is. Take out the 2 here. I'm left with 5 over 9. Over here, I see 3 goes into these two numbers, so that makes a 3 out of 4. Well, I can't reduce them any further. Those numbers are not the same, so no, those two numbers are not equivalent. On the next one, I see that this one can be divided by 6. That's a big number there. If you didn't see the biggest number, you just start off with maybe 2 and then kind of work your way down. You'll see that 6 eventually goes into those numbers. That makes 3 out of 4. Over here, well, take out a 3. I can't take a 3 out of 16, so we're going to have to fix that. Let's take out a 4 instead. Take out a 4 from 12, a 4 from 16. That leaves us with the same fraction, 3/4. So yes, these two fractions are equivalent. So again, if you can reduce the fractions down, and they are the same exact fraction, yes, then they are equivalent. Over here, well, 38 and 15, the only numbers that go into 15 are 3 and 5. 3 does not go into this number. 3 plus 8 makes 11, and 3 does not go into 11. So 3 doesn't go in there. 5 doesn't go in there because this one ends in an 8. So I cannot reduce this one. So I could reduce this one. I could take out a 5, and you see how this would be 5 over 2. Well, this one's 38 over 15. These are not the same fraction. So this one is a no. Looking at our next set of directions, it says write each as a mixed number. Well, what you're going to do is take the 7 and divide it into 43. Top dog goes in this doghouse. Well, 7 goes into 43 6 times. And do some subtraction. You're left with 1. And see how we have a remainder of 1. The way we're going to write that is 1 over 7. So the answer is 6 and 1/7. Whatever the remainder is goes on top of the fraction. The divisor, whatever this number is, goes on the bottom of the fraction. So let's take a look at our next one. 5 into 27. 5 times 5 is 25. So we're left with 2 left over. So notice that 2 is the remainder. 2 is going to go on top of the fraction. And just so happens that 5 is the divisor as well. So 5 goes on the bottom. So it's 5 and 2/5. Next one here, we have 8 into 55. And so 8 goes into 55 just about 7 times, but not quite. So we've got to go with just 6. That makes 48. And when I do the subtraction, I'm left with 7 left over. So you see how I borrow, and then I have 15 minus 8 makes 7. So it's 6 and 7/8 is the answer. So whatever the remainder is goes on top of the fraction. The divisor is on the bottom of the fraction. 11 into 80. Well, 11 goes into 80. We have 7 times. It makes 77. Do some subtraction. We got 3 left over. So 3 over 11. So 7 and 3/11 is our answer. Well, look at our next one here. It says to write each as an improper fraction. So we're going to do the reverse. So what we do is we take the 25 and we multiply it by the divisor, 5. And then we add the numerator, and then it's all over the divisor. So 25 times 5 makes 125 plus 2 over 5. So that makes a total of 127 over 5. Next one here says 11 and 7/9. We're going to do 11 times 9 plus the 7 is all over 9. So we go ahead and multiply. I get 99 plus 7. Again, that's all over 9. So we add those two numbers together. That gives us 106 all over 9. So 106/9. And the next one here, we have 4 times by 12 plus 11 all over 12. So we're multiplying the whole number by the divisor, add the numerator. And it's always over the divisor. So that makes 48 plus 11 all divided by 12. And we go ahead and add those two numbers together. We get 59. 59/12. Well, the last one here of this type, 5 times 16 plus the 5. All over the divisor, 16. And so when we go ahead and do 5 times 16, we end up with 80. And then we have to add the 5, and this is all over 16. So we go ahead and add those two numbers. We get 85 over 16. Well, last type of problem. It says Ted ran 5 miles in 24 minutes. Al ran 10 miles in 36 minutes. Well, they're pretty fast. Did they run at the same rate? Well, the rate just means like miles per hour. Well, if I was to write that as a fraction, per is the division sign. So I could do this. I could take miles and divide by the number of hours. And so I could write this as a fraction and see if the two fractions are equivalent. So I'm going to write that down. 5 miles over 24 minutes. I'm going to see, does it equal 10 miles over 36 minutes? So what I want to do to see if those two fractions are the same is I want to reduce them to see if they end up being the same fraction. Do they reduce to the same fraction? So I'm going to take out a common factor here of 2. I see that goes into those two numbers. And so when I do that, I end up with a 5 over 18. So this is reduced. I can't reduce that anymore. Looking at the next one, 5 over 24, well, that does not reduce. So does 5 over 24 equal 5 over 18? No. No, so they did not run at the same rate. No, they did not run at the same rate. Well, those are the types of problems that you're going to see on tonight's homework. Good luck.